Hello everyone. In this video, we will understand normal probability distribution. We start with the basics of this distribution, including PDF and CDF. Then we'll move to properties of normal curve and how to see tabular value from the Z table and how they will be used in particular problems. So start with the introduction. You have seen in many real life measurements like the student marks in a class or height of student or height of people in particular city or even the errors in measurements, they follow a similar pattern or similar trend. And what is this trend? Most of the data points or the values clusters are centered around a particular average value or mean value, while very few lying away from it. So this natural pattern is well described by probability distribution known as normal probability distribution. And this was given by Carl Friedrich Gauss, so also known as Gaussian distribution. So let us see what is the probability density function for this distribution. So here x be a continuous random variable, and it follow normal distribution if its PDF is given as in the given box. So we have f of x mu comma sigma equal to 1 upon sigma root 2 pi exponential minus 1 by 2 x minus mu upon sigma whole square, where x and mu are lying in real numbers and standard deviation sigma is always positive. So whenever x follow normal distribution, we write as x follow normal with mean mu and variance sigma square. So what are the parameters of this normal distribution? They are mu and sigma. So if you have a problem of finding a probability of x lying from x1 to x2, so how to find this probability? So as usual rule, it is a continuous type of distribution. So we have to integrate the given PDF of this distribution from x1 to x2. That means you have to integrate from x1 to x2 this fx comma theta, where theta has two parameters, mu and sigma. So this is this is not always easy to obtain. So what we will do, we will change this particular uh, x variable in a new variable which is known as standard normal variate z. So here is standard normal variate, and certain values of this z is given, so it is easy to calculate this probability of x lying from x1 to x2 by changing x variable into z. And what is the transformation here? The transformation is defined as z equal to x minus mu upon sigma, which we can write simply as variable minus mean of variable divided by standard deviation of the variable x. And clearly, by definition, that x follow normal distribution with mean mu and variance sigma square, this z will follow normal distribution with mean 0 and variance 1. And because x is normal random variable, so any linear combination of it will also follow normal. So z will follow normal. And how this mean is 0 and variance is 1, let us see it very clearly here. So we have now here E of x, we have to compute E of z here, which is mean of z. So this I can write as the expectation of z is defined as x minus mu by sigma. So I will use the definition here, x minus mu upon sigma. Now using the properties on expectation, this 1 upon sigma is a constant. So it will come outside and we can write it as and the bracket we have E of X, that is additional property of expectation, and minus E of mu. Now in the next what we have 1 upon sigma sts, and then here I have E of X is mu itself and minus E of mu. So mu is already a constant. So expectation of constant is constant. So it has also mu here. And finally what we have 0 here. So mean of Z is 0. Similarly, you can find variance of Z, and this means where of x minus mu upon sigma, which is by definition of variance. 1 upon sigma is constant, so it will come outside as squared. And then in the bracket, we have variance of x minus variance of mu. So now this is 1 upon sigma square into variance of x is sigma square here. And because mu is constant, so variance of constant is 0. So I have now here 1. So it is derived that Z will follow normal distribution with the mean 0 and variance 1 whenever x will follow mean with mean mu and variance sigma square. So now let us see what is the probability density function for standard variate Z here. So it is given as the PDF of standard normal variate is given as phi of Z equal to 1 upon root 2 pi e power minus Z square by 2, where Z lying in real numbers, and its cumulative given as, so cumulative is basically you have to find the integral up to Z. So P of Z is less or equal to Z value. You can say Z1 here, some particular value. So it will be Z1 here. And then minus infinite up to Z1 and then phi of Z. So this is equal to, because phi Z is also continuous. So it is equal to area under phi Z from minus infinite up to Z1. So this is your phi Z. Sometimes it is also denoted by capital F of Z. So this is actually for values of Z. This phi Z is given in the Z table. This we will again recall and will come when we discuss the problems. Let us see now what is probability curve here. And it's very, very important, and you can say the key point, key concept to understand the normal probability distribution. So if you understand this fully, normal distribution is easy for you, and it will be very helpful in calculating the problem's probabilities. So what this curve basically is, this curve is the graph of PDF of normal distribution here, x equal to mu, and this total range of x is divided into 3 type of intervals or 3 ranges. So in the x-axis you have this x values, and y-axis we have probability, that is this f of x mu sigma. So you can see here x equal to mu is the mean of this particular curve, and the left side area is same as the right side area, and total area under curve is 1. This is because fx is PDF, so minus infinite up to infinite, fx comma mu comma sigma is equal to 1. So total area under this curve is 1, and maximum area lies up to 3 sigma. So this area from x equal to mu up to x equal to mu plus sigma, and mu x equal to 0, this mu up to mu minus sigma. So this range is called 1 sigma range. So this range is called 1 sigma range, and its total value is 0.68, or this probability is 0.68. And if we talk about the area, how much it is covering, so it is covering 68.26%. So 1 sigma equal to around 26. So this 68% around. And if I move one more sigma, that is from mean value, we go up to 2 sigma. So mu plus 2 sigma here, and mu minus sigma minus 2 sigma left side. So if I go here, so this entire 2 sigma range is given as 95.44. So 2 sigma is given as 95% around. That means from total area, 2 sigma cover up 95% portion. And if I move one more sigma, so mu minus 3 sigma left side here, and mu plus 3 sigma right side here. So we have covered maximum region, and how much is covered? That is called 3 sigma range, which is 99.72%. So 3 sigma range is equal to 99% approximately. So what is left over outside, which is very, very small, around 0.0027. So most of the area is covered in these 3 sigma ranges. And that's why we have a table of these values in terms of Z. So let us see what is Z and how we can label these ranges in terms of Z. So Z equal to x minus mu upon sigma. Now I can change the x values in terms of Z here. So when x is equal to 0, sorry, x equal to mu here, what is Z value? I can write here when x equal to mu, so I have mu minus mu upon sigma, which is 0. So this at this point, we have Z equal to 0. And if I go right side at this point, corresponding to this, I have x equal to mu plus sigma. So if I put here mu plus sigma minus mu. So this mu and mu cancel, divide by sigma. So we have Z equal to 1 here. And if I go here for this value, x equal to mu plus 2 sigma, I have Z equal to 2. Similarly, you can find that Z equal to mu plus 3 sigma, I have Z equal to 3. And left side, when x equal to mu minus sigma, I have Z equal to minus 1. And at this point, when x equal to mu minus sigma, 2 sigma, I have Z equal to minus 2. And at x equal to mu minus 3 sigma, for this particular value, I have Z equal to minus 3. These all can be checked by putting x equal to, by using Z equal to x minus mu upon sigma. So just replace the mu x value at these particular points, you will get corresponding Z values. So now these three intervals or ranges you can mention as when it is 1 sigma. So in terms of 1 sigma, your Z range is from -1 to 1. In case of 2 sigma, your Z range is from -2 up to 2. And in case of 3 sigma, your Z range is from -3 up to 3. And these I have written properly here. So I hope you understand this normal curve and its basic structure. So here I have written the properties as area property. So the same is here for 1 sigma x, you have the probability is 68%. In terms of area, it is covering 68% portion of the curve above the x-axis and under the curve. And so for z, p of z from -1 to 1 is this one. and for 2 sigma it is 0.95, and for 3 sigma, that is from z equal to -3 up to 3, it is 0.9972 or 73. So these are commonly called as 1 sigma, 2 sigma, 3 sigma ranges. And most important property of this normal curve is this curve is symmetric about x equal to mu, or you can say at z equal to 0. So this half of the area, this left side area under this curve is 0.5, and the left side area under this curve is 0.5. This is also useful many times while computing the probabilities in the problems. So I can write here by using this symmetric property. I have written here. So this curve is symmetric about the mean mu, and the total area under curve is 1 because the curve represents the graph of PDF of normal distribution. And third property is normal curve approaches uh, horizontal x-axis asymptotically. That means it will appears to touch x-axis but will never touch, and it is asymptotic towards x-axis. And now here by using this curve, I can write down some trivial kind of probabilities. So let's say I'm writing here P of writing 0 to z less than or equal to 1. So because we already know this from -1 to 1, it is 0.68, that means 68%, and the curve is symmetric. So which I'm talking about? I'm talking about the area from here up to here is the 1 sigma. I want from z equal to 0 to z equal to 1. That means this region. So this is 68 divided by 2, that is half of 1 sigma. So I can write this as this is equivalent to -1 less or equal to z less or equal to 0, and this is half of 1 sigma. So 0.6826 divided by 2, which is 0.34 up to 2 decimal places. And similarly, P of 0 less than z less or equal to 2, which is equal to P of -2 less than z less or equal to 0. This is 0.9544 divided by 2, which is 0.47 around. And for half of third sigma range, 0 is less than z less or equal to 3. This is equal to P of -3 up to 0. And this is 0.9972 divided by 2. So this will be equal to 0.49 around up to 2 decimal places. So now this is all overall summary of the area property of the curve. Depending on the z values obtained in the problems, you can use these area properties, or you can use z table values. So let us now summarize what are the main steps for solving a particular problem. So first of all, we have to identify the parameters of the distribution. That is, you have to find what is the mean given in the problem and what is sigma given in the problem. Then you have to identify what probability exactly you have to find out. That is, you have to write down what are the x1 values and what are the x2 values, for which you want to calculate the normal probability, where x is normal random variable. And then, as I said, we are not integrating the PDF for given range of values x1 to x2. Instead, we are converting these x1, x2 values in terms of z. And because z PDF is simple and statisticians have given a table of z values up to 3 sigma range values. So those z values will be used to compute the required probability. So we will change into z. That means we have to change this x1 in terms of z1 as x1 minus mu upon sigma, and x2 I will change as z2, and which will be x2 minus mu upon sigma. So problem of finding the probability from x1 to x2 is now changed to probability of finding z1 to z2. So this I have to find out. So once we have converted this x1, x2 into z1, z2, x1, x2 into this z1, z2 values, we have to draw normal curve, a rough kind of normal curve because it is symmetric, and we can label these z1, z2 values on x-axis and identify the region, and we can shade the region which particular area we required or which probability we want. And depending on the z1, z2 values, we can then use either tabular values or area properties. So these are simple 5 steps for problem solving. I hope you understand, and we will see in this coming simple example. So example 1 I have taken to illustrate the process of solving a normal probability problem. So here given is x is normally distributed where mean of x is 12 and standard deviation is 4. Then find the following probabilities. So you have to find what is p of x is greater than 20, and then what is p of x lying from 0 to 12. So as simple, what is given? X is given as normally distributed between mu and sigma square, where mu is equal to 12 and standard deviation given is 4. Then we have to find p of x greater than or equal to 20. So this is your first step done. What is second step in the process? Second step is to write what probability exactly you find. It is also over. Now convert x in terms of z. So you have to find this p of x is greater or equal to 20. Now third step will be to convert this x into z. So when x is equal to 20, what is z? Z will be x minus mu upon sigma. And this means this z will be 20 minus mu is 12 divided by 4. So this implies z will be 8 by 4, which is 2. So x equal to 20 is changed into z equal to 2. And this means the third step is now this is changed to p of z, x is changed into z, and greater or equal to 2. Now fourth step is draw the normal curve and set the region. So I have now here a small rough kind of diagram I can make. So here is the normal curve. Remember that the y-axis represents probability, and this probability cannot be negative, so no portion of the horizontal line should come below the x-axis. And this curve will never meet x-axis. So here I have z equal to 0, and we want to compute for z is greater or equal to 2. So it will be somewhere here, z equal to 2. And we want this positive right side region because it is greater. So this area we want to find out. Now look at recall the area property and check out how you can find out. So I just said the curve is symmetric about z equal to 0 mean value, and the right side area is 0.5. So now if I remove this unshaded area from 0.5, which is total area, from this up to the entire curve above the x-axis. So I can write this as 0.5 minus the area from z equal to 0 to z equal to 2. So that means this is as minus p of 0 less or equal to z less or equal to 2. And this is well known. We can write as 0.5 minus. This is half of the 2 sigma range, which is 0.4, 0.95 or 9,544 is half, so 0.477 around, which is the value is around 0.228. So this is your first area under the curve, or you can say probability that x should lie above the x equal to 20. Now the second problem, we have to find x lying up to 0 to 12. So let us do that also. So in the second part, we have to find p of 0 less or equal to x less or equal to 12. So this I have to find out. Then this we have to find out z values for x equal to 0 and for x equal to 12. So I need to find z1 for x1 equal to 0. So z1 will be x1 minus mu upon sigma, which is 0 minus 12 upon 4, which is minus 3, and z2 for x2 is equal to 12. So x2 minus mu upon sigma. So this will be 12 minus 12 upon 4, which is 0. So z equal to minus 3 up to 0. So this implies the problem of finding 0 less or equal to x less or equal to 12 is now changed to finding the probability from z equal to minus 3 up to z equal to 0. Now we have to make the normal curve. So here is the rough of normal curve, and here is z equal to 0. Now we have to find up to minus 3. So this is z equal to minus 3. Now I can set this region. So okay, actually z equal to minus 3 will somewhere more left side, because it is the upper limit of the maximum area. So it should be around here. So z equal to minus 3. So this entire area you have to find. And we have seen from minus 3 to 3, what was the area? Which was around 99.73%. So this will be same as p of 0 less than z less or equal to 3. And this can be written as 0.9972 by 2, which is equal to 0.49. So this is the half of the 3 sigma. So this is how you can compute the required probability in the problem. So let us come with the second problem here. And this is an electrical firm manufactures light bulb that have a life before burnout that is normally distributed with mean equal to 800 hours with a standard deviation of 40 hours. Find the probability that bulb burns between 778 and 834 hours. So here it is clearly mentioned that the electric firm manufactures light bulbs that have a life. So X is random variable denoting life of light bulb. And X follow normal distribution with mean mu and variance sigma square, where mean is given as 800 hours, although unit is not required here, and sigma is given as 40 hours. And you have to find the probability of this bulb burns between 778, so 778 initial, then bulb burns out, and then 834. So this probability you have to find out. So these are the two steps we have covered. Now, as I said, in third step, you have to change this x1 and x2 into z1 and z2 so that you can obtain what is p of z1 less than z less or equal to z2. So let us obtain these. So when x is equal to 778, what is z1? Z1 is x1 minus mu upon sigma, which is equal to, this will be x1 as 778 minus 800 divided by sigma, which is 40. So this will, gives you 0 point, which is in negative 0.5 and 5. Similarly, when x2 is equal to 834, what is z2? Z2 I can obtain as x minus mu upon sigma. So this means your z2 will be 834 minus 800 divided by 40, which is equal to 0.85. So now third step is also completed. This implies probability of finding 778 and then 834 is now converted into Z. So it is from minus 0.55 less than Z less or equal to 0.85. So what is next step? You have to draw normal curve and set the required region. So I have now this kind of normal curve here. Let us try to make it smooth. Yeah, it seems symmetric and smooth also. Although my art is not good here. So this point is z equal to 0. And now set the indicate the given points. So we have minus 0.55, which is half of minus 1 around. So I have, let's say, here this point is z equal to minus 0.55, right side 0.8, so around 1 here. So I should write, label it here. So this is z equal to 0.85. So basically I have to set this region here, and this is the required area I need to compute, or the probability required here. So how to find this particular area or this probability, we have to think here, because the values you obtain of z here are non-standard and we are unable to use area property of normal curve. So I have to think about the phi z function, which I mentioned earlier, phi z function is the area under curve from minus infinite up to z, or phi z1 if I said. So area from minus infinite up to z1, which is phi z1. And that means uh, if I need to compute here this shaded area, what I should do here, we have to find out this phi z value at phi at 0.85. If I compute this, so this will be 0.85 phi of z. So area from minus infinite up to this point. So this entire area up to minus, from minus infinite above the x-axis up to this point, I can write as here this p of z is less or equal to 0.85. And from this, if I subtract this unrequired one, so from minus infinite up to this point, if I subtract here, you can write here, up to this, if I, from up to here, if I subtract, I get required. So this up to z equal to this point, minus infinite to this point, total area, minus from minus infinite up to z equal to this point, I need to subtract. So P of z is less than or equal to minus 0.8, this 0.55. And so this is can be denoted by a phi of 0.85 minus phi of minus 0.55. And I have these values particularly given in the problem. Yeah, it is given as 0.8223 and 0.2912. So I have now this as 0.8023 minus 0.2912, which is as 0.511, which is answer, which is required probability. And now if you want to see how to check out this value and this value, let us go with the table here. So in the table I have z equal to minus 0.55. So I need to compute phi of minus 0.55, which is p of z is less or equal to minus 0.55. So I have to go to the first z value, the first column, and select this value up to 1 decimal place. And then I have to move to these columns for the second digit after decimal. So like minus 0.5 is given here. So I will go at minus 0.5, which is here. And in this, it is 0.55. So I have to search out from the top row, hit the 0.05 column, and then I have to find out the intersection, which is this value, 0.2912. So the value mentioned in the problem was correct. Now second value we required is 0.85. So it is given in the positive table. So structure is same here, and it is 0.85. So I have to go in this z value at 0.8, which is here. And then I have to go for column number 5. So here. And now find out the intersection. So I have this 0.8023. This is the required value. So you can find any value, and it is given up to 3.4 in positive values, and in negative it is also given up to 3.4. So it is covering around 3 sigma range and beyond that also. So now next problem you can try is this here. And this is simple if you understand the process of solving a normal uh, distribution problem. So here it is given as x following normal distribution with mean mu and variance sigma square, where mu is given as 50 and sigma is given as 10. And you have to find the probability that x assumes a value between 45 and 62. So this is the first step. Now in the second step, you have to find out P of x lying from 45 up to x up to 62. So many have questioned that whether we should include this equality sign or not. So normal distribution is a continuous probability distribution. So whether you include the equality sign or will not include, it will not change answer because point probability is 0 in case of continuous random variable. That means if x is continuous, so p of x is equal to a is 0. So whether you include this or will not include, it will not change anything in case of continuous random variable where normal distribution is continuous here. Now we have to change, as third step, we have to change these x values into z values. So I will convert here these as when x1 equal to 45, what is z1 equal to 45 minus mean 50 divided by 10. So this value comes out minus 5 by 10, 0.5 negative sign. And if I go with the x2 as 62, so what is z2 value? So x2 minus mu upon sigma. This is 62 minus mean 50 divided by 10. So 12 divided by 10, which is 1.2. So this means your P of finding 45 less or equal to x less or equal to 62 is changed to probability of finding minus 0.5 less than z and up to 1.2. Now how to find this particular probability? We can check out here how to find this probability, and fourth step is we have to draw normal curve. So after drawing normal curve, we will set this region. So here it is given as, we can check out with the normal curve. We have here this normal curve. So z equal to 0, and then I have z equal to 1.2 here, and then left side we have 0.5 minus 0.5. So this is the required area you have to obtain. So this I can obtain by computing the area from minus infinite up to this point. From minus infinite up to this point, and then I subtract this unrequired area from the total. That means I can now write as P of z is less than 1.2. That means is equal to phi of 1.2 minus, that means the area from minus infinite up to this point, up to this, the total from minus infinite up to that point, total area. And then I can subtract this unrequired, which is from minus infinite up to minus 0.5. So this is z is less than or equal to 0.5, which is phi of minus 0.5. So I have to check the values of z as 1.2 and phi this z as minus 0.5. These values are 8849 and 0.3085. And we can verify. So at 1.2, if you check out the value here in the table, at 1.2, it is exact matching here because it is up to one decimal place. So 8849 is the value. And if I go at minus 0.5, so I have to go negative and minus 0.5 here. Yeah, this value. And this is 0.3085, this value. So in case of non-standard Z values, which not cover up with the area property, these values of Z, whether there will be given in the problem or the table can itself be provided in the exams. Only we have to think about how to set this region so that we can do this step required. So here is your answer. So I hope you understand this normal distribution area property and how to check out the tabular value from the table. And here I have listed some examples for you. You can try by yourself. So here is the fourth one. And in this, you have to compute the life of a battery is assuming as normally distributed. Find the probability that given battery will last less than lost in less than 2.3 years. So you have to find out P of X is less or equal to or simply less than 2.3 years. This you have to find out. Similarly, you have next problem here. Example number 5, and that you can try yourself. So this is all in this particular video. In the next video, I can cover the sampling distribution and central limit theorem, which is direct application of normal distribution. And also we will try to make a difference between normal probability problems and the problems based on central limit theorem, and what are the key differences between these two, as central limit theorem is a concept of sampling distribution. Okay, so this is all in this video. Thank you all. Thank you for watching. If you have